Hello, welcome everyone. Welcome to this webinar organized by GSMA. The webinar is about advancing the 5G era, the benefits and opportunity of 5G Advanced. So my name is Barbara Parello from GSMA. I'm the Executive Director for Advanced Air Mobility and IoT, and I'm going to be leading the discussions and moderate the whole webinar. So now we can go to the agenda, so you can view who are the participants. We have a great selections of distinguished speakers, which are the experts on the 5G Advanced from the standardization point of view. So we're going to open it up with a keynote from China Mobile, and we have Mr. Hunan, which is the Vice Director, for the Department of Wireless and Terminal Technology Research within the China Mobile Research Institute. Then we will have the presentations from Benoit Graves, is the head of 3GPP RAN standardization in Orange. Afterwards, John Gao, the 5.5G General Manager in Huawei. And we're going to conclude the presentations with Olof Lieberg, the head of 3GPP RAN standards within Ericsson. After the presentations, we will have a panel with 3 of our presenters, and we will have a conversation with all of them. And then we will just have a closing. So again, thank you for being here. I just want to open up just a little bit to give you an overview of why we are here and what we try to achieve. So if we go to the first slide, to the next, please. So why are we here? So we're talking about 5G and the evolution of 5G to the second generation. So we try to understand in this webinar what is 5G Advanced, what is the time limit that we expected for 5G Advanced, what are the benefits and the opportunities that it brings, and also why it is so important, so why we're talking about 5G Advanced, and also how we can work collectively and how you can join the conversation if you would like to. So if we go to the next slide, we try to look at a little bit of the timeline. I'm sure that maybe the speakers will give you more information, but in the evolution of the generations and the 5G evolution, so we have normally 2 phases of each generation, like we had for LTE Advanced, 5G Advanced. So the second phase of 5G, it's called 5G Advanced. And it starts with release 18 of 3GPP, and it will continue probably, as we can see, in the three cycles until release 20. But obviously, there's always changes in adaptation later on. So here you have a little bit of the timeline overview. So if we go to the next slide, so here we want to talk about what are the benefits, what 5G Advanced brings to us. We can look at the 2 aspects, very generic, and we will go more in detail with our speakers to understand what are the benefits that 5G Advanced bring. So one is the 5G has provided, let's say, the foundations of all the framework and improve some of the capacities, the speed, the coverage. But when we look at the 5G Advanced, basically we will see that there is an enhancement. So it's refining all these capabilities that were already existing in 5G, but bring it to a next level. In addition to that, you will also see that there's a range of different use cases that 5G Advanced will bring supports for. So there is a lot of features that will help to finally achieve and support this use case better. But we will see more on the presentations. If we go to the next slide, so we're just going to officially announce that today GSMA has launched a white paper that is covering the 5G Advanced. We try to give you a very brief but also high level, understandably, hopefully for anyone, what has this feature included and what they're used for. So this white paper is on our website. You have the link there, but don't worry, we will also post it then on LinkedIn, so you will have the visibility of where it is. And this is a purpose to actually bring more information, having an understanding what it is 5G Advanced and what is the importance of 5G Advanced. If you're interested to join, then you can always contact us. We have an email in GSMA that you can reach out to us. So, and you will see the participants or the speakers in this session will also be contributed to this white paper. If we go to the next slide, this is a little bit more how you can actually help us, why there is a need to cooperate and talk to each other. We want to accelerate the adoptions and of 5G Advanced. We want to have a conversation about what is that makes it to deploy successfully. So we need to have a conversation with the ecosystem. What are the right features? And also as a GSMA, there's a lot of activity that we do to make sure that we maintain the interoperability as we always do. How you can help? You can join our 5G Hero community. So we talk and we cover different topics. And if you want to join, you can contact us on that email. All information will be available also on the link on the website on the page. So with this one, I want to basically conclude. So that's a thank you for me. And this, I think, was the last slide. So I want to start introducing the speakers. So my first speakers, as I mentioned, were going to be the keynote from China Mobile Research Institute, Mr. Hunan. Hunan, welcome to the session.
Thank you, Barbara. I'm glad here to join the webinar. Thank GSMA to provide us such opportunity to share China Mobile's experience on 5G research and promotion. So my topic is 5G Advanced, targeting for sustainable 5G future. So let's begin with the slides. Next page. Okay, so this slide shows the overall status of China Mobile's 5G deployment. So there are some numbers. At the end of Q2 this year, we already have nearly 1 million base station, 5G base stations, which is more than 30% of the base stations all over the world. And we also have the users, so 5G users, 5.11 million. And especially for the verticals, we already signed more than 11,000 industry commercial use cases, including mining, factory, harbor, power plant. So in all, China Mobile has built the world's largest 5G standalone network already. So next slide. So behind the successful commercialization of 5G deployment is our continuous contribution in 5G standardization. We already laid 81 3GPP work item or study items and submit more than 7,000 technical documents to 3GPP. So our contribution and influence in 3GPP is ascending in the 5G era. So the next slide. So both the success in the 5G deployment and the 5G standardization calling us to think about the future of 5G. So last year in August, we started the 5G Advanced plan to explore the future of 5G. We defined the 3 key directions and 10 key technologies of the 5G Advanced. You can find the details in the white paper we published last year in August and this year in June. I will not go through the 10 technologies one by one. I will select 4 of them to have a brief introduction. Next slide. So the first one I would like to introduce is cross-layer technology. So as we know that XR is the bridge between the cyberspace and the real world, it's also to empower the Metaverse. So in 2025, the VR software market will reach $35 billion and the number of VR devices will reach 70 million. So that is a huge opportunity for us, especially for operators. And in order to seize the opportunities, we need to overcome the challenge for deployed XR traffic widely. So regarding the traffic, the demand of is the high throughput and the low latency that's requiring the massive radio resource. So that's making the run capacity is the bottleneck. How to handle this? We think the answer is cross-layer. So cross-layer information sharing and the cross-layer cooperation that will achieve the global optimum. For instance, if the service be aware of the run status, we can have coding and the transmission combining. Also, we can have adaptive code rate and content adjustment. If the run will be aware of the services, we can have the scheduling, which considering the frame level protection and the differentiation on the importance. We believe that through the cross-layer information sharing and the cooperation, we can achieve the performance on the capacity. We also developed the prototype with Huawei and Migu, which is the service provider and also the terminal provider called Nolo. From the test, we see that with this the cross-layer technology, the 5 times capacity improvement compared with the current 5G system. So that encourages us to do the investigation on this direction. We believe that cross-layer cooperation will be the key to support the XR traffic widely in our network. Next slide. Okay, so this one is I already introduced. The next one. The next slide. Okay, the next technology I would like to introduce is integrated sensing and communications. This is a hot topic in 5G Advanced and also in the 6G, because we all see the needs for the integration is the sensing and the communication together. As reported, the 10 million economic and industrial values of road surveillance, autonomous driving, and high-definition map constructions. So if we deploy the integrated sensing and communication called ISAC, that will take the advantages compared with the traditional radar system. We can have the low cost, high precision, and seamless and ubiquitous integrated coverage for sensing and communication. To achieve this advantage, I think there are 3 main aspects we need to investigate. The first one is the investigated design. We need a 5G waveform-based sensing signal design and also the software and hardware sharing to improve the spectrum utilization and to decrease the cost. The second is cooperative sensing. So the cooperative sensing means the sensing will be done in the multi-points. That will realize the seamless and ubiquitous sensing coverage. The third aspect is the architecture, the network architecture. Localize the independent and the light and flexible architecture to reduce the sensing delay and also reduce the cost to better fulfill the requirement. Next slide, please. We also developed the prototype for the ISAC technology. And you can see the picture, which is the monitoring the vehicles on the road in Beijing. So from our test, we can see the results are compared with the radar system. We have a longer, nearly 5 times longer distance for sensing. And also in terms of the distance resolution, velocity resolution, and the angular resolution, ISAC has much better performance than radar system. So the ISAC is a promising technology in 5G Advanced to cover both the requirement for the sensing and the communication. So next slide. The third technology I would like to introduce is the UDD, which is short for the Unified Time and Frequency Division Duplex. We see the UDD as the breakthrough of the TDD performance because through this technology, every UE in TDD band at any time is free to choose the opportunity for downlink or uplink for communication. So that will fundamentally change the paradigm for the spectrum utilization. So it initiates a new paradigm for the spectrum utilization. The key technologies for the UDD is how to suppress the interference, including the self-interference and also the cross-link interference. Also, we need to keep in mind that we need to design the efficient configuration and the scheduling signaling for the UDD system. So next slide. We also developed some prototype for the UDD technology, and from the test result, we can see that 1.4 Gbps uplink data rate is achieved within the 4 milliseconds delay. So that means the UDD satisfied the requirement of the uplink high data rate and also low latency simultaneously in TDD spectrum. So next slide. The last but not least technology I would like to introduce for 5G Advanced is called extended IoT. So that is the coding 3GPP for ambient IoT, which is just approved last week in RAN plenary as a study item. So as we know that this technology is trying to cover the use cases of the identification and the sensors of the RFID. There are huge market requirements for this. We can see that for the vertical industries, including the retail, smart grid, medical instruments, and the logistics, are predicted to contribute to $12.2 billion in this year. But at the same time, RFID has some changes to fulfill all these requirements due to its limited coverage, high cost of deployment, and maintenance, also not supporting the positioning function. All these features, all these shortages to limit the commercialization of the RFID. So 3GPP decided to try to bridge the gap between the technology and the real requirement and extend our IoT technology. So that's, we prefer to call it extended IoT. To achieve the requirement from the real network, from the commercial utilization, I think there are 4 aspects we need to focus on. The first one is the coverage enhancement. The second is the cost and the complexity reduction. The third is the tech positioning, and also we need to support widely deployment. That means they're connected to multi-service servers. So the next slides also show the prototype for extended IoT. Compared with RFID, the coverage 10 meters, our ELT extended the coverage to 200 meters, which is 20 times. Also, we can see the advantage on the wide area cellular network for the deployment, and also can do the automatic inventory. So we can conclude that ELT is a promising technology instead of RFID for the use cases of identification and sensors. So next slide. This slide shows CMCC's view on the 5G Advanced roadmap, including our strategy and the technology research, standardization steps, and industrial promotion and application innovation. So next slide. So maybe you will think that we go far, but we believe, quote from the alert, that Only those who will risk going too far can possibly find out how far one can go. So at here, we encourage the whole industry to work together with us to go far, go fast, and go steadily to explore the 5G Advanced, to explore the future of the 5G. So at the end of my speech, there will be a short video to introduce the effort from China Mobile on 5G Advanced, and to show how far we already go. Okay, let's see the video.
The metaverse is just around the corner. XR devices are now common consumer products, driving the development of multiplayer VR games. Currently, a backpack is needed for local rendering of XR games, limiting the gaming experience. Also, it is costly and takes time to provision the content. Cloud rendering solves all these with great ease. Cloud rendering requires high bandwidth and low latency. This is why only 2-on-2 play is supported with current cellular capacity. This is where cross-layer collaboration in 5G Advanced comes in. It gives the highest priority to the iframe transmission, which is essential for XR. So, given the same capacity, 10-on-10 play can be possible. And such play can be made regardless of location and viewed by audience. This will certainly boost the XR industry ecosystem. To support XR of 8K, 16K, 64K, and even higher resolution, and multi-person interaction with the virtual world, 5G Advanced will further support large bandwidth spectrum and extremely large aperture array massive MIMO. This will allow the network to deliver 10 Gbps and MS level latency, ensuring fully immersive experiences. 5G Advanced will quickly scale up XR Pro's adoption in gaming, tourism, education, and industrial diagnosis, bringing us to a true metaverse world. Video production has increasing demands for higher resolutions and multi-camera shooting anytime, anywhere. For networks, this means growing demand for higher mobility, as such wireless backhaul will be necessary. In addition, video post-production requires that HD videos retain high fidelity with shallow compression during transmission. To solve this issue, 5G Advanced UCBC uplink-centric broadband communication uses multi-carrier aggregation, uplink-only spectrum, and extremely large aperture array massive MIMO to improve the communication capability tenfold, ensuring gigabit uplink. China Mobile utilizes dual-carrier UDD based on 50 MHz SUL and 100 MHz TDD to push the limits of spectral efficiency. It is the first in the industry to achieve an uplink cell throughput of over 3 gigabits per second and an uplink peak rate of over 1 gigabits per second for a single user. In smart manufacturing, typical industrial applications such as video surveillance and machine vision have great demand for uplink capacity. Estimates indicate that the uplink service demand in indoor industrial scenarios will reach 1 gigabit per second to 1.5 gigabits per second per 1,000 square meters in the future. As we move into an intelligent, fully connected world, and 5G Advanced ultra-large uplink make gigabit uplink network ubiquitous, enabling more innovative applications, including intelligent connected vehicles, automatic patrol vehicles, and cloud robotics.
5G-A, 5G-A, double I come together.
Thank you, Mr. Yunnan, for the presentations and also for the insights or the work that you're doing in China Mobile Research Institute. So thanks you very, very much, and I hope the other MNOs or other participants will be interested to, as we mentioned, to join the community and have a conversation on how to drive it forward, be fast, as you mentioned. Thanks again for the participation. And now we can go to the next speaker. So we want to welcome Benoit Graves, which is from Orange, and is going to bring the perspective of Orange. Thank you, Benoit. Over to you.
Hello. Hi, so I'm Benoit Graves. I'm head of 3GPP RAN standardization for Orange. I will give a perspective from Orange in terms of the main drivers for 5G Advanced. we move to the next slide, we see 4 different pillars basically for 5G Advanced. I would say, as usual, some higher performance on the network, more services than what we've done so far with 5G, and operational benefits as well, both in terms of energy efficiency and intelligence on the network to run with more automation our operations. If we move to the next slide. So it's really a subset of what we think is most promising. There's a lot of other features involved, but for higher performance, we're thinking we need, performance comes with bandwidth and spectrum, and the next big major band that we foresee is 6 GHz licensed, which would be deployable in a macro network in a similar fashion as 3.5 GHz. Is specified in Rule 17 in 3GPP, but now it's in discussion for approval in Europe at CEPT level, and we're supportive of this and approval at the WRC 23. So it's very significant chunk of spectrum for deployment. And we also look at the uplink services, which where we require more performance in the uplink specifically for some B2B services that are looking at what we could instant upload. For example, a train arriving at a train station with lots of data collected around the journey needs to upload this very quickly. And also mass events where users are uploading media content like video to the on social networks. And for this, we have the evolution of the duplex. So it's a kind of hybrid mode between TDD and FDD that China Mobile explained just before. That will give more flexibility to us to put more uplink on these TDD frames in 3.5 GHz. But with the constraint of managing the interference, our main scenario is between the kind of macro network that have a unified downlink-oriented frame and some specific indoor or stadium or locations that would have more uplink. And we need to manage the interference between the two. Next slide, please. On services, the first service we see is XR. So XR is supported on the networks. We already can provide XR services, but we can do better in terms of managing situations with low coverage or lower capacity. And to do this, we need some awareness from a network point of view to know that this is XR and a specific characteristic in terms of latency and throughput requirements. If we need to guarantee the integrity of a frame, for example, we need to know. So there need to be interaction between the services and the network. And a lot of services coming up, like cloud gaming, a lot of application for B2B, Metaverse around the corner. And we also need to manage the power efficiency, because these devices may be quite greedy in terms of power. And if we can optimize the power saving of these devices, it would be the best. Moving to the next slide, please. So for other services, whole angle on IoT. So IoT so far in 5G has been mainly 4G IoT with relying on LTM and narrowband IoT, which provide the kind of massive IoT services branded with 5G. Here we're looking at other segments. The first segment with red cap is mid-range, I would say, and that would take the requirements of mobile broadband and lower some constraints on terms of number antennas, lower the complexity. And we see this as an evolution from what we have today in LTE, what we call category 1 or 1bis, which is kind of mid-range device for smartwatch, for video surveillance or industrial wireless sensors. And the next one is what we call now ambient power IoT or extended IoT, as China Mobile hinted, which has been approved as study item last week in the plenary, which is a form of zero or ultra low energy type of device. So looking at the extending the RFID with better performance, better coverage, and also some ultra low complexity sensors and asset tracking to be able to have a very, very low cost, low complexity device with almost no energy or none, using RF, the energy from the RF or some small storage with solar energy, to provide this kind of very low-end type of services that we've not addressed so far with 3GPP technologies. Next slide, please. So the next service is the satellite. So satellite really has a potential to provide a solution for what areas where we have no solution so far, white zones. It can be the desert or ultra-rural areas where we have no terrestrial option that has been reasonably possible to deploy. So here we're talking about direct connectivity from the satellite to the smartphones and a range of devices for automotive or public safety. It also includes IoT technology like Narrowband IoT and LTE-M. And there is some improvements with the low orbit satellites, for example, that the coverage and the capacity now becomes more interesting than in the past. So here there's really potential for complementing the terrestrial services, not replacing, but complementing. Next slide, please. So now from operation of the network, the power efficiency is, as you can guess, is a critical element from our network, both from a perspective of CO2 emission and also from the cost of energy. We have some ambitious target within Orange with 30% less CO2 emissions by 2025 compared to 2015, and also a net zero carbon target by 2040. And here, Release 18 is really taking a more ambitious target for power saving with when we're modeling this network energy consumption, but also taking this as a criteria when assessing the performance of the new features, so that we can make a decision in the best technical choices, also taking into account the efficiency in terms of energy. And some techniques to go much deeper into the granularity of switching off in time, frequency, or spatial domain, different transmitters in a more dynamic fashion. And moving to the next slide. So the last area wanted to hit at is the intelligence of a network. So here, AI/ML, which is which is addressing a lot of different areas today, is entering the area of the RAN. And we see this as a way to both optimize the performance, also increase the operational efficiency with more automation on the optimization of the network. So here, what we need is some standards that can drive an open and secure framework with control from the operator perspective. So more specifically, we're looking at optimizing the interface, and now we're looking at optimizing beamforming or positioning accuracy with AI/ML, but also a lot of user case from radio resource management point of view to optimize the mobility, the load balancing, and also the power saving. So this is a very promising area that we're looking at, and that will change somehow. That could change the way we operate the networks. So that's completes my presentation on the drivers for 5G Advanced. Thank you.
Thank you, Benoit. Thank you for the presentations. And we wait for you then in the panel. So we go to the next presenter. So now we're going to have John Gao from Huawei. John, welcome to your presentations. Please, over to you.
Okay, thank you, Barbara. Yeah. Ladies and gentlemen, very nice to see you. And I'm John Gao. Today I will share our thinking about the pave the way to 5.5G. Next page, please. So in the past 3 years, 5G achieved great success both in the deployment and the commercialization. In terms of the number of commercial networks and the terminals and the subscribers, 5G developed very fast, more than any generation before. And also for the up value and the DAU growth, it also achieved a very good ratio. So next page, please. So because of the growing of diversified service, the network still need enhanced for future. For example, for the XR service, it required both downlink and uplink symmetric large band OS, and also low latency and guaranteed performance. And for the 2B scenario, it required super large uplink, connected vehicles, and high precision positioning. And for the IoT service, people want the very low cost and the medium speed IoT terminals, and also the ultra low cost passive IoT. 2 years ago, Huawei announced the vision for 5.5G. And 3GPP also defined the 5G-Advanced last year. So after 2 years, work together with the industry, operators, vendors, chipset, and terminal companies, we think the 5G can provide these key features for all the subscribers. The first one will be support 10 Gbps in downlink. Second one is can support 1 Gbps in uplink. And third one will support 100 billion connections for IoT, and also support the native intelligence and the native green. So this is till today we think are the most important values for 5.5G. So next page, please. For 10 Gbps, many people may ask, can we support 10 Gbps in wireless? Because it's already reached to the similar speed like fiber. With the ultra high bandwidth like a millimeter wave and the 6 GHz, we can support the 10 Gbps. And also with the technology enhancement, like a memory enhancement and the COM enhancement. So next page, please. So to support the peak data rate for 10 Gbps is not a challenge, but how to support ubiquitous 10 Gbps is a major challenge for vendors to provide the value for operator. So with ELA technologies, which we are be supported in 5.5G, we use more antenna element to enlarge the coverage for the higher spectrum. So for example, for 6 GHz, in this video, we did the prototype and did the test. It can reach the similar test result with C-band. So the ELA can complementary like a 7 to 10 dB coverage. This will help the higher frequency band to reach the ubiquitous 10 Gbps in the network. Next page, please. So for the uplink is always a bottleneck for 5G because 5G enhances the downlink by 10 times, but uplink is similar as the 4G. In 5.5G, we will develop the uplink and downlink decoupling technology for the ultra high uplink with the multi-band convergence. For example, for the TDD band, like C-band and 4.9 GHz band, even in the future for the 6 GHz band and millimeter wave band, the downlink we can use the ELA to enlarge the coverage. But uplink, because limited by the transmission power and also the transmission resource, the uplink coverage is still the bottleneck. So we could use the FDD spectrum like 1.8 GHz, 2.1 GHz, and 700 MHz and 2.3 GHz to boundary like one carrier, which can doing the convergence and support gigabps in the uplink together. So we call it the flexible spectrum access. So this technology is defined in the 3GPP release 18. We think this one will help operator to make the TDD spectrum much more valuable and can enhance the coverage and also uplink user experience. Next page, please. So for IoT service, today we have a lot of wireless technology can support IoT, which caused the industry very fragmented. So in the 5.5G, we see the opportunity to converge the IoT connections to 3 mainstream. The first one is RedCap. RedCap is defined in release 17, and it targeting to the billions level middle speed terminal connections. This one, we think this will last maybe for next 10 to 20 years. It will be very important for all the IoT connections. Second one is NB-IoT. This is very familiar for everybody, and we think this one can support 10 billions levels connections for the low power wide area connections. In release 19, 3GPP will define the passive IoT. This one can support tens of billions passive connections. The passive means it can with only a labor, with the battery-free connections, and with very low cost, and also with limited transmission capability, which can support the reading and the sensing collect. We believe this one will be very popularly used in many scenarios and can really support 100 billion connections in the next 10 years. Next page, please. So besides of the communication capability, in the 5.5G, the base station can support the sensing capability as well. So with the reflected beam, and we can do the signal processing to sense the objective. So we can sense the speed, the distance, and the image for the objective. And also the base station can do the multiple set coordination very naturally. So this one provide us some opportunity to achieve the better performance and more accuracy than the existing radar. So the video shows what we developed a prototype in the vehicle scenario. We can support the smart transportation with our base station's new capability. And we believe the sensing capability will be used in the smart traffic, smart fencing, and low sky security scenario, blah, blah. This one will provide a new opportunity for operator to open the new market. So next page, please. So today's network is more and more complex because we have to handle multiple dimensional service requirement, like the downlink throughput, uplink throughput, and latency and reliability. Also, we have the varying capabilities of different bands, like the TDD band have a large band OS, and the FDD band have the symmetric capability, and the millimeter wave have a super large band OS, but maybe uplink is not so well. And also we have the construct to do the energy saving for 100 with 100 times traffic growing in the future. So how to make this challenge and doing the native intelligence design in our network is a topic for us. So in the 5.5G, we are doing the real-time awareness for all these informations in the frequency, domain, and throughput and interference in any perspective. And also after the big data we collect, we will doing the analyze and the prediction in the base station. Then based on this analyze and the prediction, we can do the intelligent decision making to make the optimize the performance. We expect with the intelligent run in 5.5G, we could achieve 50% performance gain and more than 10 times energy efficiency. So next page, please. We have one page in the last page. So let me summarize the 5.5G. So first of all, the 5.5G will continue enhance the existing scenario like ENBB, MMTC, and URC. And the key capability will be downlink support 10 Gbps, ubiquitous user experience, uplink 1 Gbps, and support 100 billion connections. And also we support native intelligence and native GRIN. And also the 5.5G will open new market with new revolutionary capabilities like sensing capability and passive IoT, and also the high precision positioning and intelligence. So this is my presentation, and thank you very much.
Thank you, John, for the presentation. We will see you then in the panel shortly. So now we can go to our final presenter, Olof Liebeck from Ericsson. Olof, over to you. Just a note, you're very dark on the camera, but it's okay. You're getting better. Yeah. Thank you. Over to you for the presentation.
Thanks, Barbara. Thanks for the introduction. It's a pleasure to be invited to this session with such a distinguished set of co-speakers from across our industry to discuss the future of 5G and then particular 5G Advanced. So today I plan to introduce a few of the defining components of 5G Advanced. And I must say that I'm pleased to see that the information just shared by my colleagues aligns fairly well with the content of my material. But with that, let's go to the first slide. So I think it's important to notice that 5G Advanced is not a standalone solution. It builds on all the good work we've done in the past 5 years or so in 5G. 5G, as you all recall, supports mobile broadband, critical and massive IoT since the start of the 5G NR journey in 3GPP release 15. And then in the past two releases, we've added support for carefully selected verticals. We have connected industries. We added support to connect critical communication in the railways domain. We are addressing satellite communication, as just pointed out. So with that said, it's important to know that some of the key components that we establish in 5G, they continues its evolution also in 5G Advanced. Another good example is the advanced support for massive and advanced antenna system, which is a pillar in 5G and continues to be one also in 5G Advanced. But the rich 5G Advanced scope also, of course, offers new exciting developments. For example, we will accelerate the focus on providing sustainable and intelligent automated mobile networks. We will also follow the principle already established in 5G to strengthen the support for existing services, such as immersive reality. It's been highlighted by the previous speakers. But we're also developing new device types that can provide these type of services to the end user. But first, let's focus on how 5G Advanced can increase our focus on providing sustainable cellular networks. So let's go to the next slide. So already 5G was fully focused on sustainability and improving the radio access network power efficiency. So compared to 4G LTE, as a very basic example, several so-called always-on transmissions were redesigned and turned into on-demand transmissions to make the network leaner and less power hungry. The work now is accelerating, which is very important, and Ericsson's together with the entire 3GPP industry is focused on working towards making our networks even more energy efficient. Release 18, the first one in 5G Advanced, will develop a detailed network power consumption methodology that has two purposes. First, I would say in short term, to help us identify new opportunities for improving the energy efficiency in our networks. Perhaps even more important in the long run, it will help us to develop features that provide sustainable gains. Release 18 is just starting, but already now some opportunities have been identified for supporting energy savings. especially in low-loaded scenarios, where the network transmissions can be made even more leaner. With leaner, I mean less frequent and of lower power. But there's room to consider improvements also when devices are connected to our networks, luckily. So the active parts of the massive antenna systems that we discussed earlier today, they're quite power hungry. And if we can adapt those to the immediate needs of the end users, we have the opportunity to further reduce the power consumption on networks. These are opportunities that we look now during release 18, so the next 12 months or so in 3GPP. Okay, but reducing the network energy efficiency is also a target in the work to make our networks even more intelligent, which then brings me to the next slide and next topic. So 5G-Advanced is working on enhancing support for artificial intelligence to support a higher degree of automation in our networks. In 3GPP, this work is highly use case driven. And as already pointed out, in the first release 18, the focus is on network energy efficiency, load balancing, and mobility management. A key component is to enhance the existing system with the methods to do richer data collection. For determining the mobility of a device, we could, for example, ask the device to report its expected velocity and direction, perhaps even trajectory, and the network can then proactively prepare for efficient and seamless mobility and load balancing throughout the cellular network. Release 18 also considers how AI can improve the 5G air interface functionality. The work now is focused on studying enhancements for channel state information reporting from the device to the network, how we can optimize beam management and positioning. If we focus shortly on positioning, it's often based on a method called triangulation, where we try to estimate the distance between a device and 3 or more network nodes, as I illustrate here on the picture. If we know the distance between the device and these nodes, we are able to determine the whereabouts of the device. But triangulation works best when there is a clear line of sight condition between the device and the involved nodes. So what's being explored now in 3GPP is how we can train the system using AI to detect these line of sight conditions for improving the location accuracy and reliability. Automation and energy efficiency that I just touched upon are generic improvements. I would say they apply to almost any features that we develop and provide in 3GPP. But we are, of course, also working on specific features, and extended reality, or XR, is one of the most high-profile items. That brings us to the next slide. So extended reality, also known as immersive reality, is in 3GPP an umbrella term that covers cloud gaming, virtual reality, and augmented reality applications. From a radio access network point of view, what is distinct for these services is that they demand high data rates at a fairly short bounded latency. This combination is quite tough and poses new requirements on our radio access network. So the work to optimize 5G support for XR started actually already in the previous release, but is now accelerating in 5G-Advanced. And the prime focus is to leverage application knowledge to optimize the network efficiency to provide these challenging services with a good bounded latency in a power efficient manner without sacrificing the system capacity. So again, to exemplify, consider a video stream with a frame inter-arrival rate typically corresponding of 60 frames per second. If the radio access network, so the device and the base station, is made aware of this quite distinct packet inter-arrival rate, we can, of course, optimize our scheduler accordingly to optimize the resource usage, to increase the capacity, and make both the network and the devices less power hungry. Okay, 3GPP is not only working on facilitating new cool services like XR, we're also addressing new device types that may support, for example, XR. And that brings me to the final topic of the day on the next slide. So as I said, 3GPP continues to work to enable new applications and connect new device types. The latest example in this category is perhaps RedCap, reduced capability devices. It will provide cost-friendly and power-efficient connectivity to wearables and industrial wireless sensors, to make 2 examples. Key enablers here for this reduced cost and complexity, and also to enable a compact form factor for the device, which is a key when we are talking about wearables, is to reduce the number of required receive and transmit antennas and branches, and also reduced transmit receive bandwidth. While a 5G mobile broadband modem that you find in your typical smartphone can be expected to support between 2 and 4 receive branches and over 100 megahertz of bandwidth. These RedCap devices can work on as few as 1 receive and transmit antennas over just 20 megahertz of bandwidth. To put this in a perspective, one can compare it with typical LTE category 4 device. RedCap devices will support peak data rates ranging all the way up from 50 megabits and above. So it's not as close, as low complex as, let's see, LTE, MTC, and urban IT devices that offers the most basic massive IT use cases, where cost pressure is quite high on the device side. So it addresses a slightly higher level in the massive IoT range of use cases. Okay, to summarize then on the final slide. So before I round off my short presentation, to summarize the 5G-Advanced pillars that I present today. 5G-Advanced will accelerate the work on sustainable and intelligent networks, and it will continue to provide and facilitate cool new applications and services such as XR and wearables. And again, thanks for inviting me to this webinar. It's been an honor to take part of it. Thanks.
Thank you, Olof, and thank you all the presenters. So now we can continue and move to the last part of the webinar, which is going to be a panel session, Q&A for all our presenter. So in the meantime, when I see you all setting up, I just want to let the audience that if you have questions, please type it in. We will try to do our best to pick up and answer the question that we receive. We will not be able to answer all the questions, so apologies if you feel that we didn't address your question. Also, if you have issues on connectivity, the server is working properly, so you might need to refresh or reconnect sometimes to get a better connection. So, but let's start then with the panel. Let's maybe go back to the original points where we said why 5G Advanced is important, and what do we see why we need to deploy before going to the 6G. Let's start maybe first with John, and then we go around the table. John, what would you say?
Yeah, thank you, Barbara. I like to share what I'm thinking. So first of all, I think the 6G will come maybe 2030, around 2030. So for the industry, in the coming maybe 10 years, we still need to enhance the 5G to meet more and more requirement for the end users. And also in the 3GPP, we already defined the 5G Advanced brand. It will start from release 18, and maybe we'll continue to release 19, 20, even 21. So the progress will maybe finish at around maybe 2028 or 29 sometime. And also, we think that this 5G network is very good, but for future, new service will coming, like Meta maybe. We heard some company will announce, maybe publish the new terminals, like XR terminal. In the future, the network still need further enhance. And also, for the IoT, we need more and more capability and more low-cost terminals to support for the new energy saving vehicles, and also for passive IoT, blah blah, a lot of scenario. And also for operator want to open a new opportunity with the sensing capability. This also we saw a lot of requirement from the drone detection and CV2X this smart transportation, a lot of companies required to the operator and want to get some support and some service for this kind of sensing capabilities. So we believe in the next 5 to 10 years, the industry required 5G Advanced, and also 5G Advanced will provide more and more value for the industry. Okay. Thank you.
Thank you for this one, John. So maybe let's go next to Olof, and then we close with the view of the operator. Olof, over to you.
Yeah, thanks, Barbara, and thanks, John, for the nice reply there. To a large extent, I agree with you on the basic principle that 6G is some years away. So there's a good time window now where we should certainly be able to make something really good out of 5G Advanced and offer that to the market. As I highlighted in my presentation, we see some pillars that we believe are strong already now, but will grow during the evolution of 5G Advanced. And again, I really think it's time for extended reality or immersive reality to take off. And I think what's happening around Metaverse is really exciting and fuels that use case. But then also I think a key is sustainability that I believe GSMA also lives in the white paper that's being published today. So sustainability is really important for our society. We've done a lot in 3GPP, but we can do more. And now we're really taking a closer look at that in 5G Advanced.
Thank you, Olof. And Benoit, obviously, you as an operator, you are the one to deploy the network. So we would like to hear what is your view, why it is important 5G Advanced for an MNO?
Yes, we totally agree with what the message from Olof and John, that 6G is some way away, and we definitely don't need to wait for 6G to develop a number of technologies that can be very well supported in 5G. If we look at what 5G has been so far, it's been mainly mobile broadband with the Release 18 baseline, and we still have the 5G core to deploy in most of our operations, and with everything that comes with it, like slicing and much more differentiated quality of service that would facilitate both some more B2B type of services and optimize a number of more demanding services. So if we look at the pyramid that we had, like mobile broadband, URLC, and massive IoT, URLC is not really materialized in this way. I mean, it's a little bit of private networks, but not with all the low latency and high reliability that we thought initially. And massive IoT has been mainly 4G IoT extended, FPWA extended to 5G. So a lot more we can do in the IoT remit, as we said, with RedCap, passive IoT, and services like XR and Metaverse, and that really can be sustained efficiently, we think, in 5G if we do it properly. And the other angle is operational of the network. And from an operator, it's very important we maximize the way we operate the networks. With 5G, is even 4G and the legacy. We're switching off some legacy technologies, but 4G and 5G will be there for many years. And from an energy point of view, it's very critical, but not just that, also from a flexibility point of view, to automate these networks, we need also openness. I mean, there's other initiative as Open RAN, going to the virtualization of networks, and that could change a lot of things in the way we do operate the networks eventually. And again, this is not 6G, it's something that can happen much before.
Thank you, Benoit. So maybe let's recap on some of the topic of services and feature that we actually see in your presentation. And I stay with you, Benoit, since you just mentioned it. So you talk about IoT. How do you see, so if you can elaborate a little bit more from your perspective, how you see this evolution, why this changes, what it will bring, what is the opportunity of IoT with the 5G Advanced?
Yeah, I mean, 5G as a whole is quite a broad range of technologies and user cases. From the very basic sensor to some much more advanced cases with video and different type of things sustained. So traditionally for an operator, we still have a lot of machine to machine in 2G actually and 3G, and these things need to evolve over time. We think that 4G has done a good job in assessing what we call the low power wide access with a much extended coverage, a 20 dB gain compared to what we had. So to reach much further the devices. 5G is a different angle. 5G is not replicating this. We're not reinventing the wheel. We keep the 4G options for the extended coverage, and we're looking at new segments. And the new segments is more this kind of mid-range that would benefit from the higher performance of 5G. We were talking about the wearables, the smartwatch, for example. It makes sense that it's moved to 5G with more capacity and higher bandwidth, high spectral efficiency. And so this angle is important. But also for 5G industrial sensors also, we think it's important for the B2B industry. We have to be aware that some of these business may deploy only 5G, for example. So they need a 5G IoT option. Also, the passive IoT or ambient powered this range, which is much lower complexity and lower cost than we'd ever done in 3GPP. Again, this is another segment. So eventually we see it, the whole picture would be a mix of technology, some 5G, some 4G, maybe a little bit of legacy 2G for a while, and this evolving further.
Thank you. Then maybe let's have a thought from, what do you think, John? What is, from your perspective, the importance of IoT in the 5G Advanced? Do you agree with Benoit?
Yeah, I totally agree with Bennett, and I think for the 5G Advanced, there is a big opportunity for the IoT stuff. First one is for the traditional connections, IoT connections. Maybe 4G capability is not enough. It needs enhanced for the future. And another one is new opportunities. Today, the whole network, the whole society move to the digitalization and move to intelligence. So all this requires more and more data collected from the terminal side and uploaded to the cloud and doing some training and some analysis. So we think this is a very big opportunity for the IoT. And another opportunity is for the detection and the sensing. A lot of sensing need to transport the data to the network. So we designed the passive IoT. This passive IoT can help people to use very low cost and use no battery-free terminal to support this all these kind of connections. Yeah. So we think I think the IoT in 5G Advanced will be more and more important and more valuable for operator.
Thank you, John. And Olof, you also had in your slide, obviously, IoT, so I presume it's also important for you. Can you give us some views?
Yes, definitely. And yeah, I tend to agree with the summary given by Benoit and Orange that we already know that since 4G, since release 13, we efficiently address the massive IoT segment. We even have two valuable systems there, Narrowband IoT and LTE MTC, that's been widely deployed around the globe. So a very successful use case. And now, as pointed out, the reduced capability device category is addressing the IoT segment above that. I think in release 17, so the one that was just finalized, we are looking at peak data rates in the range of 50 megabits per second, so significantly higher than what we see in the LTE MTC domain. We will take a step down to 10 megabits per second in release 18 to to balance complexity and capability. But still, these devices are quite capable, and I think from Ericsson's side, we see them as fairly interesting, for example, for XR applications, where you have more moderate data rate requirements. The advantage there is that the lower form factor requirement, which makes them suitable for wearables, not only smartwatches, but also smartwatches. So that's a really interesting development that we are seeing. Then on the, let's see, we call it ambient IoT now in 3GPP, but this zero energy IoT segment, that's of course a very interesting opportunity that we will just start looking at now. So it will be very exciting to follow that and see where that leads.
Thank you. Thank you for the view on IoT. So we at least cover one of the, let's say, the corner of the 5G triangles. Let's maybe then go to another perspective, John. So you had a lot in the presentation, but also with China Mobile, we saw there is an improvement on the performances for the uplink. So can you tell us a little bit to who actually, what will be the benefits and who will be the most, let's say, important user in this area, because you had some examples. So, but can you elaborate a little bit more what you see from your perspective?
Okay, thank you, Barbara. It's a very good question, actually. In the past several years, I did a lot of investigation for the applications in uplink. So first one is in the 2B scenario, we can see the manufacturing requires a huge, large uplink capability. Everyone knows. So the second one is for the 2C traffic. In the future, if XR is popular, XR requires symmetric bandwidth both in downlink and uplink. So the uplink is also very important. And today, a lot of young people like doing the live broadcast to share their life and many moments. And in the third direction, I discussed with a lot of car manufacturers. I found a new requirement actually for in the future. Most of the car will support the assistant automatic driving. So this will require each car transmit a lot of uplink traffic to the cloud to help the car company to do the training and analyze and information collections. So this is a huge market for the operator in the future. And the last one is the cloud-based service and the AI-based server is deployed more and more in the world. So all the cloud-based server and all the AI server, they require a lot of uplink traffic data to do the big data analysis. So that's the reason we think uplink is very, very important in the future. In these four scenarios, will be benefit for the 5G Advanced. Yeah.
Thank you, John. And let's then go to a topic that I guess everyone wants to know about now, because it's a very, let's say, is everywhere. You will read about Metaverse, what it is Metaverse, and what 5G Advanced can do for Metaverse. So maybe we start, let's say, from Olof, and then we share the other thoughts. Olof, what about Metaverse and 5G Advanced?
Yeah, thanks, Barbara. Yeah, it's really exciting with all the news around Metaverse. I really think they can also benefit the good work we are now putting into 5G Advanced. Already in my slides, I touched upon extended reality, where that's closely related to Metaverse. And as I said, I think we've been working on it already since release 17. We will continue to do so in release 18. And I see this as a pillar in 5G Advanced that we will continue to enhance also in the coming releases. I think application awareness, as I said, is a key, that the radio access network can be made aware of let's see, key characteristics of the service. And this, of course, also applies to Metaverse. Then I would like to point out that it's not only in the radio access network where we are addressing this and enhancing the support for it. We, in the system architecture area, have exciting work ongoing for something called application rate adaptation that I think will be a real key for this to work efficiently. As I mentioned, I also think the RedCap devices perhaps it's not that intuitive to think of something that we're developing for IoT would be applicable to XR, but thanks to their good characteristics aspects when it comes to providing more, let's say, device of a smaller size, smaller form factor will be really interesting for these use cases, especially if the data rate requirements are not the most stringent. Then, as you know, we're in the cellular business, so mobility is vital, and of course something that will benefit a service like Metaverse that you want to take anywhere with you. And also for mobility, the great work we started in 5G now continues in 5G-Advanced, and we have some dedicated topics on enhancing it to make the connectivity and end user experience seamless as you move through our networks. So certainly, I think there's many parts of the work we are doing now in 5G-Advanced that will be beneficial for addressing Metaverse.
Thank you, Olof. No, Benoit, what is your perspective from an operator on the Metaverse? What do you expect to be Metaverse for you?
Yes, well, may start by saying that Metaverse is a wide range of services. It's not just a single Metaverse. It's quite diverse in terms of what it can be. Okay, it can be XR to simplify it. It could be cloud gaming, but augmented reality, which have different requirements. It could be 2D, it could be 3D, and it could be quite a range of devices. Okay, you may have the kind of helmets and glasses, but also you may support this on a normal smartphone if you interact with a smartphone or a laptop. It's fixed and mobile. It's not just not mobile. So all of this require quite a lot of interoperability between the devices, between the system, and between the providers. Metaverse is not necessarily a single provider of services. So it's our role from the standards point of view to make this interoperability happen. And for this, we think that we need also to interact properly with APIs, for example, with this system. That will clarify the inputs that are needed from the application and also the interaction with the operator. From our perspective, we can do a lot with QoS differentiation. We already have slicing as, I would say, a baseline to work with. And as we discussed today, we need to do a lot more. And in Release 18, we could do more. Having more awareness of these services, we can maybe guarantee the frame, or we can maybe use some kind of layering of QoS with a high resolution and a low resolution. If you have lower radio conditions, maybe you only have the low resolution. These type of things are very interesting and need to have awareness from the network point of view. But this is... So this requires the standards to evolve. But what I want to say from an operator perspective, to guarantee this lower latency, this kind of guaranteed throughput, doesn't come for free. And that's we need to work jointly to see what is necessary to do and what type of architecture evolution. Maybe we need more edge computing, for example. And we need to look at the business model behind it, because as I said, if we invest to support these services from a network point of view, we need also to get the associated revenues and or shared investment. So this is really I would say the challenge for the years to come. What is needed, how to interoperability between all these systems, and how we do evolve our networks in a joint manner.
Thank you. And I don't know, John, do you have also a view from your perspective what is important in Metaverse and what 5G-Advanced will bring?
Yeah, I think 5G-Advanced could provide the three major benefits for the Metaverse. First one is for the uplink, as I mentioned in last question. And third one, I think the 5G-Advanced could provide the large capacity for the Metaverse. In today's network, maybe each sector, each cell only can support 3 to 5 users, cloud gaming users. It's not enough. It's very limited. In 5G Advanced, with the layered XR and other technologies, we can increase this capacity by 5 times. This will allow every user can enjoy about this kind of service. And the last one, we think the 5G Advanced can support the cloud-based XR service, because we will enhance the latency and the reliability to allow the cloud applications could be used in the network. This one will reduce the cost in the terminal side, and also will increase the applications. So we think this one will help the Meta develop more and more faster as well. So I think 5G Advanced will be more match and more important for Metaverse.
Thank you. And yeah, it's quite good about what you said, Benoit, that 3GPP is actually pushing the boundary to approve and provide the capabilities and stretch this capability as far as they can. But it's a fine balance between the capabilities, what's the business model, and what is actually coming out of the market because of the demand and request and willing to pay, I guess. So it's a good comment that we need to work on what actually we can offer to the customer, what it makes sense to the customer. There's a couple of questions that I want to take also from the audience. Maybe let's start with one question that was about NTN. They're talking about what is the business model of a non-terrestrial network, so satellite, 4G, 5G, and what we would like to subscribe in the rural area, who would be the customer, and also if there's an impact on the battery life on the terminal. So I don't know, Olof, maybe you want to try to give it a spin?
I will do my best. So 3GPP has actually worked during the past 3-4 releases on NTN, and I think with NTN now we're referring to satellite communication, which is perhaps the main deployment scenario. Satellite communication comprises many different type of deployment scenarios. I think when you're discussing rural connectivity, typically what you have in mind is perhaps type of fixed wireless subscription, where you will be connected, and on your house you have a smaller or larger antenna dish that provides you with broadband connectivity. I think that the most interesting work that 3GPP is doing right now is not fully in that domain. What we are trying to address currently in the start of 5G-Advanced is actually to connect handhelds, so regular smartphones. And for me, that's even more exciting and something that's not really been done earlier. And here I think 3GPP is doing quite extraordinary work to enable that. And then it will just be people like us, like anyone that has a smartphone, that will be the target subscriber group. And the way I see it then is that the business case is that the satellite link is a complement to the terrestrial link, and it's about reliability, availability, and resilience. So regardless of where you are, if you go out, let's see, in Stockholm where I live, in the archipelago over the weekend, you know that you're always connected, and that I think is one of the key use cases and business cases that 3GPP should and is focusing on right now.
Thank you, Al, for that. So indeed, as you mentioned, the primary focus, we've been used to use satellite for backhaul, but the primary focus is actually, we already moved to support 5G as a standard instead of proprietary solution for satellite. But then the shift in the 5G Advanced is actually trying to reach that device, to not have a hardware change on a device used as you have your smartphone, not the traditional satellite with a big antenna. So that is the purpose. I don't know, anyone else want to tip in on this question? Otherwise I can try to see the other questions. If not, there was a questions about, I don't know if any of you actually can provide some update. Did 3GPP work on the 5G Advanced to improve capabilities in the broadcasting, multicasting, broadcasting. Does anyone want to pick that question?
I can say a few words about it. So
Sure.
already in LTE, I think we had great support for multicast and broadcast. In 5G, we have specified the same support. So we have support for broadcast and multicast. It also continues now in 5G-Advanced, and the purpose then is to make it even leaner. And I believe that you can then provide multicast or broadcast to devices that are not in a connected state. So it will increase the scalability of the solution that we have just implemented in the specifications in the past release. So work is certainly ongoing, and that applies also to 5G-Advanced.
Thank you. So there's also a question coming in, but maybe I can quickly give an answer. So there's a question about optical solutions. So as far as I know, in 3GPP, for 3GPP Advanced, in the current stages, there is no discussions on how to use or how to integrate optical in it. That doesn't mean you cannot use it, but it's not the primary focus, I would say, on 2GP Advanced. So you will see that there are examples of how it's used, for example, for backhauls or other type of things, but not in the primary scope of release 18, as far as I'm aware. So there are we're getting actually close to the ending. So we just maybe are going to close and ask a question to all of you. So if you had to, I know it's a difficult one, but if you had to tag 5G Advanced with 3 words, what would be the 3 most important words you will use for 5G Advanced? Shall we start maybe with, I don't know, Benoit, do you have it already in your mind? I know it's a difficult question, but...
No, I think we can say advanced services, sustainability, and intelligence.
Good. Maybe Olof, I see that you are laughing, so let's see.
Yeah, great mind thinks alike. Yeah, I was also about to say advanced, sustainable, and intelligent. So yeah.
We're pretty much aligned. That's good to see.
Yeah, that's very good. Yeah.
And what about John? What about the 3 for you?
Yeah, I think it's 10 Gbps downlink, 1 Gbps uplink, 100 billion connections, and intelligent and green.
All right, so thank you. So I'm looking forward, as I mentioned. So it is important, and maybe I wanted to stress again. So we are in that phase that the standard is evolving, but there is a need to get together and work as a community together to make sense of the standard, I would say, make sure that it's actually you can use it. So there's a lot of activity within the GSMA with our members that we need your inputs and your thoughts so that we do the right thing and we accelerate the deployments of 5G Advanced. Any last words for any of you?
Only thanks. It's been a pleasure to be part of this event, Barbara.
All right. So for the apologies. So for the audience, as I mentioned today, we published the white paper. It's available online, but we will repost the link of the white paper. So feel free to download it, read it, and reach out to us if you want to get in touch with us. So the other things that I want to mention, so the recording, it will be still available on demand in LinkedIn. And we will see after the recording, we need some time, but we will see if we make the slides available for you on our website. So you can also have the availability of the slides. And with this one, I thank you, everyone. Thank you, all the presenters and my distinguished speakers. So it's a pleasure to have you here, and see you to the next time. Thank you.